Okay, so now let's look at exercise 8. Exercise 8 is actually a more challenging question. So you're told that you have a 2 dm³ flask containing gas N, and the pressure was 700 kilopascal. So then you connect it to another flask containing gas M, and the volume is 3 dm³ and pressure is 400 kilopascal. So now imagine if you were to open up this cord here, and you're supposed to now find out what is the final pressure of this whole thing, assuming that the two gases don't react and everything is actually measured at the same constant temperature. So to calculate the final pressure, right, or rather the final pressure, what you can do is there are actually two methods that you can do lah. So let me introduce to you the first method. The first method is you just simply add the amount of gas present. So you must remember PV is equals to nRT. So now we all know that the constant thing here is definitely your molar gas constant, and T is also constant. So what it means is that PV is proportional to N. So as the gases do not react, right? So we know that the amount of M plus the amount of N is equals to the total amount after mixing. So this will be what happened. So we know that PM times Bm plus Pn times Bn will be equals to the P total times B total. Okay, so originally it was 400. So for gas M, it was 400 times 3 plus 700 times 2. So this will be equals to the P total, and the V in this case will be 2 plus 3, right? When I open this out, the total volume that the gas particle can occupy is actually 5 dm³. So as a result, PT will be equals to 520 kilopascal. So that's one way of calculating. Another way of calculating is using the partial pressure method. So I can calculate in terms of gas N first. So remember the Boyle's law, all right? So we say P1V1 equals to P2V2, am I right? So I can also say this is P before mixing is equals to P after, right? So this is what Boyle's law says. So I can just look at gas N first. I know that it was 700 times 2 equals to what is the P N after the mixing. So the volume after mixing is still equals to 2 plus 3, which is 5, the total volume. So therefore, the pressure of gas N after mixing will be equals to 280 kilopascal. I can do the same thing for gas M. So same thing here is P before V before equals to P after B after. So it's the same as the P1V1 equals to P2V2 according to Boyle's law, right? So it will be 400 times 3 equals to P M after times, again, the total volume is 5, 2 plus 3, 5. So now the partial pressure after the mixing, right, is equal to 240 kilopascal. So then what I'll do is I'll apply Dalton's law. So the total pressure is simply just PM plus PN, right? So it will be 240 plus 280. So that will give me 520 kilopascal as well. So both methods will lead you to the same answer.